Hi everyone, in today's lesson we're going to talk more about graphing rational functions. This time we're going to talk about a rational function that has a slant asymptote. So let's look at example number 1. So just like we did yesterday, we're going to find the factors first to find any holes and vertical asymptotes. So step 1 will be to factor. So I know I can factor the numerator because it's dots as x plus 4, x minus 4. And I can factor the bottom to take out a GCF of 3, and I'm left with x plus 3. So since nothing cancels, we have no holes. So we can go ahead and write that, no holes. And we know that to find a vertical asymptote, step 2, we set any leftover denominators equal to 0 and solve. So here's my denominator. I'm setting it equal to 0. I'm solving. 3 equals 0 makes no sense, so I get to reject that. X plus 3 equals 0. I can simply solve. So I get x equals negative 3. Now, if I want to find some horizontal asymptotes, I know that I have to look at the original equation, and I have to look at the degree of the numerator and the degree of the denominator. So the degree of the numerator is 2, and the degree of the denominator is 1. So we know that the degree of the numerator is greater than the degree of the denominator. And if that's the case, there is no horizontal asymptote. But because there's no horizontal asymptote, that means we have a slant. So in order to find the equation of the slant asymptote, we're going to have to do some long division. So we're going to take this 3x plus 9, and it goes out on the outside. And on the inside, we're going to put this polynomial equation, x squared minus 16. But just be careful, we need a 0x because we would need to have a placeholder. So now we're going to do our long division. How many times does it take 3x to go into x squared? What would I have to multiply it by? Well, there's not going to be a number that I can multiply 3 by to get 1, so we can just divide now. So we have a 1 in front, so we'll just do 1 divided by 3, which gives me 1/3. So we'll have 1/3, and then x times x gives me x squared. And now we multiply. 1/3 x times 3x is simply x squared. 1/3 x times 9. Well, you can think of it as 9 divided by 3, right? That's what it means to multiply by 1/3, or you could just type it into the calculator. 9 times 1/3 is 3, so plus 3x. And we subtract. So 0 minus 3 gives me a negative 3x. Then we bring down our minus 16. And now how do I multiply, or what do I multiply 3x to get negative 3x? So you should be thinking here, negative 1, and then we multiply. So negative 1 times 3x is negative 3x, and then negative 1 times 9 is negative 9, and we subtract. And then we have negative 16 minus negative 9, which is the same thing as saying negative 16 plus 9. So go ahead, type that into the calculator. And hit resume when you're ready. Okay, so you should get negative 7. So remember, the slant asymptote is just the stuff up here in the quotient. We don't care about the remainder or the dividend or even the divisor. So my slant asymptote is the line y equals 1/3 x minus 1. Okay, now let's continue and let's find our x and y intercepts. So step 4, let's find my x-intercept by setting y equal to 0. So I'm going to use this equation, right? That's my factored form of my original equation. So I've got f of x equals x plus 4, x minus 4 over 3 times x plus 3. So we're going to go ahead, like I said, and we're going to set y equal to 0. And remember, we could put the 0 over 1 and cross multiply. So 1 times anything is itself. 0 times anything is 0. So we'll have x plus 4, x minus 4 equals 0. Nice little t-chart will give me -4 and +4. Now remember, x-intercepts are points, so we're going to have to make this -4, 0 and 4, 0. Those will be my x-intercepts. Now we're going to use the same equation to find my y-intercept, but this time we're going to set x equal to 0. So we have f of x equals, just for space, I'm just going to go ahead and plug into here. I'm going to plug 0 in for x. So 0 plus 4, 0 minus 4, all over 3 times 0 plus 3. So in the numerator, 0 plus 4 is 4, 0 minus 4 is -4, and on the bottom, 0 plus 3 is 3. So we have f of x equals -16 over 9. And if we made that a point, the x is 0 and the y is -16 over 9. So that would be my y-intercept. So we can go ahead and put everything here in the bottom, what I'm asking you to solve for. So the domain, remember, is going to be all real numbers except for the x values of the wholes and any vertical asymptotes. So all real numbers except, well, we didn't have any wholes, but we did have, if we scroll up a little bit, a vertical asymptote of x equals -3. So all real numbers except for x equals -3. So then that's my vertical asymptote. We didn't have any wholes. We didn't have any horizontal asymptotes, but we did have a slant of y equals 1/3 x minus 1. My x-intercepts were -4, 0 and 4, 0. And my y-intercept was 0, -16 over 9. So let's see if we can go ahead and plot this information and get our best estimate of a graph. So I'm going to plot the vertical asymptote and the slant asymptote first. So my vertical asymptote here is the line x equals -3. Okay, and my slant asymptote is the line y equals 1/3 x minus 1. Now remember, that's an equation of the line mx plus b, where b is the y-intercept. So we would start this graph down here at -1. And remember, the slope is the rise over the run, so up and over. So I'm going to go up 1 over 3, up 1 over 3. Now, since I can't go any more to the right, I'm going to go back to the y-intercept and go down 1, left 3, down 1, left 3. And since this is a slant asymptote, we're going to connect the dots using using dotted lines. So now, just to finish the graph, we can plot our x-intercepts. So if you see here, my x-intercept is -4, 0 and 4, 0. So here's -4, 0, and here is 4, 0. And it looks like I have a y-intercept at 0 and -16 over 9. So what I'm actually going to do is go to the calculator and type in -16 over 9 and figure out where that is appropriate as far as a decimal. This is probably the only time in the class where I'll actually allow decimals because we need to know where to put this. So if you put this into the calculator, you'll get -1.7 repeated. So that's the approximate value. So we can go ahead and do that. So we're at 0, and -1.7 would probably be somewhere over there. And you can kind of see now that this graph, these 2 points have to connect, and these asymptotes are going to contain it. So you probably can estimate that this branch of my rational function is going to look something like this. And you can even surmise that this branch is going to be contained between these two asymptotes. So we can just go ahead and graph that here and here. So in this example, we actually don't need any additional points because the x and y intercepts kind of gave us enough information where we could just go ahead and sketch the curve. So the last piece that we need is our range. So now remember, the range is similar to the domain. It's all real numbers except the y values of the hole and horizontal asymptotes. But I don't have any holes and I don't have any horizontal asymptotes. So all real numbers would be my range. So we can go ahead and just write all real numbers. And if you want to write down what the range would be, it would be all real numbers except y values of holes and any horizontal asymptotes, which I have neither, so it's just all real numbers. All right. Excellent work. That's it for today. If you guys have any questions, now's the time to jot them down and ask us in class tomorrow. All right. Have a good night.